Okay, so this quadratic equation is written in vertex form. So this quadratic equation easily gives us a vertex. So in here, the vertex would be so when you list a point that's a vertex, you list the opposite of the value that the x is being added or subtracted by. In here we have a plus 3, that's our h value. So because we actually subtract h in the vertex form of the formula, this is going to turn into a minus 3. So the x coordinate always gets the opposite sign. And then the y coordinate stays the same as the value of k, like that. So the vertex is minus 3 comma 1. So I'll graph it here. So minus 3 comma 1. That is my vertex. Now my axis of symmetry is the x value of the vertex, which is x equals minus 3. That is a line of symmetry that makes the parabola symmetrical, like that. It's not perfect, but it's getting there. And I'll label that as my axis of symmetry. There we go. Now this is asking me if I have a max or min value, and I forgot to put a question mark in there because the question is, do we have a maximum or minimum value? So this we're talking about either the highest or the lowest value of the y's in the parabola. So we notice that the coefficient of a is actually 1 in here. You don't see it, but if you multiply this term out by 1, it's going to be the same. So the value of a is 1. And because a is positive, the parabola will open up. So that means we will have a minimum value. And the minimum value would be the y value of the vertex, which is positive 1. And now we're going to find the y-intercept. To find the y-intercept, we need to set the value of x equal to 0. So y equals 0 plus 3 squared plus 1, which is 3 squared plus 1. That is 9 plus 1. So y equals 10. So the y-intercept is a point 0, 10. Common mistake students make is they think this is the standard form of the quadratic equation, and they automatically assume that the y-intercept is going to be positive 1. But this is written in vertex form, so you actually need to plug in the x. Okay, so now let's grab some more points. The y-intercept is at 0, 10 up here. And then we could get another free point to help us graph the parabola. So the y-intercept is 3 units away from the axis of symmetry. So we can find another point that is a reflection of the y-intercept by using the line of symmetry. So this point is 3 units away from the line of symmetry. So the point that is a reflection of the y-intercept will be 1, 2, 3 units away from the line of symmetry. And I could graph my parabola and it will be opening up. So it's going to look something like that. There we go. And that is a graph of my